Imagine a simple blog app using Postgres full text search. We search for Postgres BM25. The results came back fast, but look at what we got. A Series A funding announcement at number 2 for a search about BM25, is that right? Also, if a result like that is taking up a top spot, what else might be getting pushed down? The best match for this query might not even be on the screen. The database found matches, but it didn't rank them well. And in search, the ranking is what matters the most. Postgres can already do text search, but better search is not just about finding matches. It is about ranking them well. That's where BM25 comes in, a ranking model from the search engine world that, with the right extension, can run inside Postgres. To understand why, you need to know that search actually has 2 jobs: matching and ranking. Matching gets you the candidate set, the documents that contain the terms you searched for. Postgres full text search is good at that. It can tokenize text, build an index, and find candidates quickly. But once those candidates come back, the question changes. It's no longer just, does it match? It is, which match should be first? That is where the default ranking starts to struggle. Let's go back to the results and look closer. Here are the term counts for each result. Notice, Postgres appears dozens of times in almost every post. It's a common term across this whole corpus. But BM25 is rare, and that's the term that actually tells you what the query is about. The Series A post has 25 mentions of Postgres, but only 1 of BM25s. Those repeated Postgres hits give it more credit than it deserves. Compare that to number 1, which has both terms well represented. That's a real match. The ranking treats every term the same. It doesn't know that BM25 is the rare intent-carrying signal, and that's the problem. That's the gap teams often hit with native Postgres full-text search. It can find matching documents quickly, but when ranking quality starts to matter, teams often reach for a dedicated search engine. You add something like Elasticsearch, Solr, or Elasticsearch, tools built around search relevance. And sometimes that is the right call. But now you have added another technology to your stack, with its own deployment, its own sync pipeline, its own failure modes. You got better ranking, but you bolted on another system. But what if you didn't have to add that second system? BM25 is the ranking model that search engines have used for years to solve exactly this problem. With extensions like ParadeDB, you can bring that kind of ranking much closer to where your data already lives. The data stays in Postgres. The relevance scoring happens there too. So we are no longer just asking, did this document match? We are asking, which matching document is the best answer? The intuition behind BM25 is pretty simple. It turns 3 common sense signals into a ranking score. The first signal is rarity. If a term appears everywhere, it is a weaker clue. In our corpus, Postgres shows up in lots of database articles. But BM25 appears in fewer places, so it tells us much more about what the searcher probably wants. The second signal is repetition. If a document mentions BM25 5 times, that should usually count more than mentioning it once. But 50 mentions should not make the document 50 times better. At some point, the extra repetitions stop adding much new evidence. The third signal is focus. A short post that is actually about BM25 should not lose to a huge post that only mentions BM25 in passing. So BM25 gives shorter, more focused documents a fair shot. Here's the actual formula. It looks complex, but it is mostly those same 3 ideas written precisely. The blue part is rarity, inverse document frequency. How rare is this term across the corpus? The pink part is saturation, term frequency inside the document with diminishing returns. And the green part adjusts for document length. So BM25 usually starts with the same matching documents. The upgrade is judgment. Which matches the best answer? Rare terms, useful repetition, focused documents. That is the mental model. Here's our original ranking. Same previous query, same results we saw at the start. Now here's the same query ranked with a BM25 index. The Series A post drops out of the top results. And the results that are actually about BM25 in Postgres move up. So now we see a recommender engine post and the hybrid search guide among the top 5. Articles that match the intent of the query. Same query, same data, better ranking. And this is the key part. You don't necessarily need a second search stack to get this kind of ranking. With extensions like ParadeDB, BM25 search can run inside Postgres over the data already sitting in your tables. You create a BM25 index on the table, and the same data can now be ranked with a stronger relevance model. No separate search cluster, no sync pipeline, no second source of truth. Postgres can already find the matches. BM25 gives you a better way to order them. And when that ranking lives close to your data, search gets simpler. And when it comes to search, that makes all the difference.